Assalamualaikum and hi everyone. For this video, I will discuss about chapter 1 KSSM Form 5 Variation Part 2. Okay, still in direct variation. Our learning standard for this video to determine the relation between three or more variables for a given joint variation. For this, we have learned that we have learned only two variables. So for this video, we will discuss between three or more variables. Okay, what is the relation between three or more variables for a given joint variation? I'm sure you are familiar with this formula. This is the formula for simple interest. You have learned this in Form 3, Chapter 3, Consumer Mathematics. Okay. In general, for a joint variation, y varies jointly as x to the power of m and z to the power of n can be written as y varies directly as x to the power of m, x to the power of n. This is the variation relation. And then this is the equation form. Equal sign and add the value of k, where k is a constant. Okay, have a look at example 9. Write the relation using the symbol of varies directly and in equation form for each of the following. So, for A, this is the answer for A. P varies directly as Q and square root of R. So this is the variation relation. This is the equation form. For B, Y varies directly as the square of W and the cube of X. So B varies directly as W square and X cube. This is the equation form. C, the volume of a prism Y varies directly as area of cross-section A and its height H. So this is the answer. V varies jointly as A and H. So this is the equation form. V equals to KAH. Question D. The mass W of a cylindrical metal rod varies directly as its length E and the square of the diameter of base D. So this is the variation form. W varies jointly PD square. And then this is the equation form. This is the same way as direct variation with two variables. This one, this is for three variables. Okay. Example 10. Given that x varies jointly as y square and z, express x in terms of y and z if x equals to 6 when y equals to 3 and z equals to 5. Actually, this is the same question as previous video, but this time we have three variables. So the first step, write in the variation relation, and then write in the relation in the form of equation. Substitute the value of x, y, and z, and then you will get the value of k. Hence, x equals to 2 over 15 y square x. We just substitute the value of k here. Example 11. The gravitational potential energy, E joules, of an object varies directly as its mass mkg, the gravitational acceleration g meter per second square, and its position at a height of h meter from the ground. Given that E equals to 197 joules, m 4 kg, g 9/81 meter per second square, and h equals to 5 meter. Write an equation that relate E, m, g, and h. This is for variables. So first, write in the form of variation relation, and then write the relation in the form of equation. Substitute the value of E, M, G, and H, and then you get the value of K. So substitute back into the formula. Hence, E equals to mg H. Example 12. Three quantities S, T, and U vary as shown in the table on the right. It is given that S varies directly as T and the cube root of U. Calculate the value of X and Y. Okay. First step, you have to write in the form of variation relation. S varies directly as T cube square root of U, and then write it as equation form. And then you can substitute the value of S, T, and U as given in this table. And then you get the value of K. Hence, substitute the value of K into the formula. After that, substitute the value of T and U here to get the value of S. The S, you substitute with X. Same goes to calculate the value of Y. Substitute the value of S and T. Then for U, substitute Y. So you get the value of Y. Okay, homework, self-practice 1.1c. Next, our second learning standard for this video, solve problems involving direct variation. Okay, how to solve problem involving direct variation? Look at example 13. Charles' law state that for a fixed mass of gas, the volume V cm cube of the gas is directly proportional to its absolute temperature T Kelvin if the temperature of the gas is fixed. It is given that a container contains 30 cm cube of gas at a temperature of 30 degrees Celsius. Question A, express V in terms of T, and then calculate the volume in cm cube of the gas if the temperature changes to negative 11 degrees Celsius. Formula for the conversion of temperature in degrees Celsius to Kelvin. X degrees Celsius equals to 273 plus X Kelvin. Okay, how to solve this? First, you have to understand the problem. V varies directly as T, given also V equals to 30 when T equals to 273 plus xk Kelvin. Then, second step, devising a strategy. Write the direct variation in the form of equation. Then substitute the value of T into the equation and hence calculate the volume of the gas. So this is the same calculation that we do from the previous question until you get the formula V equals to 10/101 E. Then substitute the value of T to get the volume. So this is the conclusion. For A, V equals to 10 over 101T. And for the volume, 25.94 cm cube. Example 14. Madam soon saved her money in a saving account. It is given that the interest I receive varies directly as the principal P and the period in year T of the savings. Madam soon received an interest of 200 when she saved 4,000 for 2 years. Calculate the period of the saving of Madam soon to receive an interest of 650 with a principal of 5,200. Madam soon wants to get the same amount of interest but reduce the period of her saving in A. Does she need to increase or decrease her principal? Explain your answer. So this is the step. The first step. The first one, you have to understand the problem. In the question, mention that I varies directly as principal and time and a number of year. So I given 200, P the principal is 4,000 and 2 years. Devising a strategy, write the direct variation in the form of equation and calculate the value of P when I 650 and P 5,200. Then understand the changes for every variable in the equation. So this is in the equation form, and then you substitute the value of I, P and T to get the value of K. Then this is the equation for interest equals to 0.025 P. And then substitute the value of I and T to get the time. So this is for question A. For question B, the answer is to maintain the value of I in the equation of I equals to 0.025 P. When P decreases, T also, when P decreases, T increases. When T increases, then T decreases. It means here, if your principal decrease, your time taken increase. When your principal increase, so the time taken decrease. Okay, making a conclusion for A, the answer is 5 years. So B, the principal has to be increased to get the same amount of interest if the period of the saving is reduced. This is because the interest received is directly proportional to the product of the principal and the period. So this is your homework, self-practice 1.1D. Okay, that's all from now. Thank you and see you in the next video.